Hi everyone, thanks for joining the webinar on Azure Data Lake Analytics Deep Dive. I'm your host Ilyas. Now let's give a couple of more minutes for other participants to join. Thank you so much. All right, thanks for being on hold. I welcome you all once again for the webinar. We had a very detailed introduction on the various data lake services and technologies in the last webinar, and if you're interested to understand the introduction given about these services along with a couple of more services, I would recommend you to go through Azure Vidyapeeth webinar series and look for the old webinar in the archived section. And before we jump into the webinar session, let me give you a couple of, a quick introduction about myself. Like you see on the slide, my name is Ilyas. I work as an Azure Solution Architect at 8K Miles, and I also work as a P-seller at Microsoft. And you can also find my Twitter handle and LinkedIn profile given here in case if you want me to catch offline for further discussion in this topic. Without further ado, let's get started on the webinar content. I may give pass here and there just to push the slide to you so that you can all see the presentation that I'm presenting. So in today's webinar, we got this agenda where we will look at the origin of Azure Data Lake, where it came from and how it evolved. and then we are going to deep dive into the various components and the various services that Azure Data Lake offers. Unlike the introduction webinar that I gave earlier, we are not going to look at U-SQL capabilities or how to submit a query into Azure Data Lake Analytics. So henceforth, I'll be calling the service as ADLA in shorter form because calling Azure Data Lake Analytics is little difficult. All right, so let's get started. Okay, so let's give a quick recap from the previous session, what we discussed about, and now a little bit of introduction without going very detailed into the services or giving again introduction on the services. Right. For the big data workloads, currently there are 3 different services, right? So one that you see on the left-hand side is HD Insight. HD Insight is a very matured service on Azure for processing big data workload, and it is basically based on the MapReduce paradigm, right? And on the right-hand side, what you're seeing is Azure Data Lake Analytics, that is ADLA, and ADLS, Azure Data Lake Store, right? So these are the 2 services that Microsoft has recently come up with, and both the services are currently under preview at this moment, right? So if you go to your Azure subscription, you will not have direct access to create ADLA and ADLS account immediately. Whereas you have to submit a preview request. Both the services that we are going to dive deep today are currently under preview, right? Let me warn again, it is currently under preview. It is not at GA so far. So it is going to hit GA probably in the summer of 2016. All right, and if you ask me what is the basic difference between HD Insight and the new ADLA offering, basically the difference is if you want to run a cluster, for some reason, if you want to own the entire cluster, and if you want to manage the map and reduce stuff, and if you want to use Spark, Storm, the complete the list of open source big data technology and solution, the best bet is to go ahead with HD Insight. Right, the HD Insight gives you the complete infrastructure because you own it. You stood up the infrastructure, and you can add as many slave nodes or head nodes for processing your data based on the workload that you have. Right, so you have to understand that HD Insight is something that you run, you manage everything. Right. On the other hand, the ADLA and ADLS is a complete PaaS solution, right? So if you come from a background of Azure App Services or cloud services, with in difference with Azure VM, right? In Azure VM, you get the complete access to the box, whereas in Azure App Service or cloud service, you'll be limited access to the underlying server, right? But then the benefit is you don't really manage the servers, underlying servers, and you don't really worry about the security, the scalability, and things like that because everything is packed into the Azure PaaS service. So as a developer, you only worried about building and loading a website and publishing a website, and that's about Azure PaaS. Similarly, Azure brings the same PaaS capability for big data workload, right? So if you're a big data guy, you only care about how quickly you see the end result without worrying about standing up a cluster of servers or running a program or going through the learning curve of the MapReduce paradigm and things like that. So Azure Data Lake Service is essentially a PaaS service that gives you a complete set of tools and technologies for you to quickly push the data and get the output in a matter of minutes and seconds. So we are going to deep dive into the various components and services within Azure ADLA and ADLS. With Azure ADLA and ADLS, Microsoft introduces a new program for you to query against the big data workload, right? So don't worry that U-SQL is a new programming language, and don't worry that you have to learn a new language, right? It is not that case. I mean, if you are coming from a .NET, a typical C# plus SQL background, it is very similar. It essentially, U-SQL is nothing but a combination of C# plus SQL Server, right? So one of the reasons why Microsoft took this path of developing a new language for processing big data query, big data set, right? The problem in the current environment is if you are a .NET guy and you are now getting into a project of dealing with big data, with the existing list of tools and technologies, you may be mandated to learn the MapReduce or Java programming or plenty of other things that you have to learn to get into the Hadoop world or big data world, right? What if I am a .NET guy and I know C# and SQL and I want to process the data with my own language that I know, right? So this is the answer from Microsoft, to pull in all .NET and C# guys and make them as a big data developers, right? And one of the reasons why they combined C# and SQL, as you could see on the slide, C# is a very powerful language. When it combined with the declarative nature of the SQL, it gives a lot more power, right? So that's one of the reasons why Microsoft has come up with a unified SQL for processing big data queries. Now let's understand a bit of history and the evolution of the Azure ADLA and ADLS. All right. For Microsoft, big data is not something new, right? So they've been managing Bing and a lot of SaaS applications, the CRM and ERP solutions, and things like that. In fact, the Hotmail, Live, there are plenty of solutions that Microsoft offers. And what this makes is it brings a lot of data, zettabytes and petabytes of data, right? So for Microsoft to process these kind of data, they built something called Cosmos before many years, and this Cosmos is internally used by thousands of developers within Microsoft. And the Cosmos is empowered to query against any kind of structured, semi-structured, and unstructured kind of data, and it can handle batch jobs or interactive jobs or even machine learning jobs and streaming jobs, right? So Microsoft is now bringing the same capability and the power of Cosmos in the name of Azure ADLA and Azure ADLS. All right. So before we dive deep into the Azure ADLA service, let's quickly understand the pricing, because this is very much important before you jump into it, right? So if you look at the pricing, so here you can find analytics unit, which costs 1 point some cents per minute, and for completed jobs it costs you something. And you have to understand that currently this service in preview, and while any service in preview on Azure, there will be a 50% reduction, and once the service goes live, it will be doubled, because it is currently 50% reduction, and once it goes live, it will be double the cost. So while we get into the deeper inside of Azure ADLA and ADLS, we will also look at how you can cost effectively run your big data workloads without worrying about the compute units or Azure Data Lake units. Okay, now let's look at some of the key data ADL components. All right. So now, if you look at the current slide, you can find on the left-hand side, on the ADL Analytics account, you can find the linked service to Azure Data Lake Store. So Azure Data Lake Store is essentially an independent service for you to store a massive amount of data. And the basic difference between Azure ADL Store compared to our regular blob storage, right? The Azure ADL Store is designed for storing, batch or big data workloads, right? Unlike the Azure blob storage, right? So this is equipped enough for querying large amount of data in parallel or distributed fashion. All right. On the left-hand side, again, you can find U-SQL catalog or metadata. So this metadata is nothing but a platform bytes or the runtime which powers the big data environment. And then you've got job queues, and you can also find some of the key settings such as max concurrent job, that is how many concurrent jobs that you can run, and what is the max Azure Data Lake units per job that you can allocate, and max queue length. So we are going to look at these components in further slides. So I'm going to move fastly because of the content that I have. There are plenty of content that I want to cover, so I may rush. In case if you've got any question, please type in your question in the chat window so that I can answer it at the end of the presentation. Right. So this is a simplified workflow of how a query gets submitted, executed, and finally gives you the result. Right. So I'm sorry for that. So as per the workflow, if you can find on the top, you have a job front end. So the job front ends could be your Visual Studio from where you submit a query, or you can also submit a query using Azure portal. Right. So soon after the slide, I'm going to take you through the Visual Studio and show you how you can start submitting the query to Azure ADLA. Right. So once the job comes to Azure ADLA, it gets put into the Azure job queue. Right. So this is not our service bus queue or topic. This is specific to Azure ADLA. Right. So this is something internal for Azure ADLA. So once your job is queued, then it gets into job scheduler. Right. The job scheduler is powered by Yarn, right? Hadoop Yarn, which takes care of the complete job management and how many jobs that you schedule. And once it gets into the job scheduler, then the job that you submitted, the query that you submitted, gets compiled. Right. Gets compiled, and the compiler emits certain internal bits. We will also look at how it gets emitted and what kind of file that it emits once it compiles the job or query that you submit, right? And finally, the job manager and job scheduler give it to compiler service, and finally the compiled file gets into the U-SQL runtime, and finally your job gets executed, and the desired output will come out of the query engine. Right, now let's understand a basic U-SQL batch job. And before we get into the next set of slides, let me take you through the Azure Data Lake query submission or job submission using Visual Studio. Right, just give me a moment. Let me switch my screen to Visual Studio. And in the meantime, if you have any more questions, please put your question in the chat window. All right, I hope you can see my screen now. I have opened my Visual Studio, and here I am on the Solution Explorer. Let me tell you how I came here, how I created a new ADLA project in Visual Studio. Right. So to create a new project in a new ADLA project in Visual Studio, you have to get something called Azure Data Lake tools for Visual Studio. To get this tool, you can either go to Azure documentation or just use a friend Google and search for Azure Data Lake tools for Visual Studio. You will find it and you can install it. And once you install and restart the Visual Studio, you can find the new menu appearing on the top, right? All right. So once you have the Data Lake tools installed, just go to File and click on New and say Project. And here you can find, after installing the Azure Data Lake tools for Visual Studio, you can find a new template getting listed on the template section under C#. And here you can find a list of starter projects, right? So you can create a brand new empty U-SQL project, or you can use U-SQL sample application that comes along with the set of tools that you install, right? So now you can click on OK and create a new project. In the interest of time, I'm not going to do that. Instead, I'm going to open the existing project that I've created. So when you do that in the previous screen, you get the U-SQL project with the sample data set along with the sample queries, right? So here we are seeing one such query. Right? So like I said, I'm not going to take you through explaining how the structure of U-SQL and what are the various extractors and the functions or operations available in U-SQL, but just to give in highlight or update. So this is how the typical query of U-SQL looks like. So if you look at it, it is very similar to our SQL, T-SQL, right? And you can also find, in this query there is no C# function used, but you can also use your C# functions if you have already written in any of your application, or if you have any DLL which has got helper function, you can also bring your DLLs as such. So you got the complete C# capability inbuilt into U-SQL. So here, if you look at it extracts the schema, extract the data from a file, text file with a delimited function, and then we are applying a select condition from the result set, right? So this is how a typical query looks like. Let me also open another simple one for your better understanding. This is the hello world kind of sample. So here, if you look at, we are declaring extractor or result set, and here we are extracting a data from a tab separated file, and then we are outputting into another CSV file, right? So extractors and outputters are some operations available for you to extract and output your data, right? So once you are done, once you open this query, you can simply go ahead and submit it against your ADLA account, or you can submit it in your local computer as well, right? So you can either do it a query against your ADLA account. So for in the interest of time, I'm not going to do it. I'm going to open the existing query that I have already run. So probably if you're interested, there's nothing wrong in going and executing against it. So what I've done is I've already mapped my ADLA account. So the way that you do it is go to your Server Explorer and log into your Azure account, and once you log in, you can find your ADLA account getting mapped to your data lake project that you have created, right? So let me simply go ahead and submit it against my Azure account. Right? So once you submit the query, we can go back to our Azure subscription. Unfortunately, it has expired. Let me log in again. I hope you can see my screen. And I'm going a little bit fast in the interest of time. How likely are you to recommend? Yes, I would recommend highly. Okay. So this is the query that we just, not this one, I'm sorry. All right, so this is my data lake analytics account. I'm not going to, so if you're interested, go to new and then click on analytics and you can find data lake analytics account. But like I said, it is currently in preview and you have to raise a request to the Microsoft team for you to create an Azure ADL account, right? So I'm going to click on the account that I've already created. Okay, and here you can find all the jobs that I've submitted. And you would have noticed that we have just submitted a job through my Visual Studio, and it is currently in progress. We are going to look at what these things are and what is there on the right-hand side in detail. Now let's go back to the Azure portal and see what is happening there. Right, so you can simultaneously see the current status of the running query in both the places. Right? Okay, so let me stop the screen share and go back to my slide. And towards the end of the session, again, we will come back to Visual Studio and show you the output of this query. Let me give a couple of more minutes for the presentation to load. It is taking a while. All right, so I think the demo with Visual Studio and the Azure subscription ADLA account would have given you some idea as to how you can start working with ADLA account. Let's move ahead. Right, so this is a typical structure of how the job gets executed. On the left-hand side, what you see is, let me make it a little big for me so that I can see. So on the left-hand side, you can see the complete status of the query that's getting executed. It has got various stages, beginning from preparing, queuing, running, and finalizing. So we are going to get in detail as to what these functions are. And on the right side, you can see the complete algorithm, or how it gets executed, how the data, the big data, gets splitted into multiple different ALU units, Azure Data Lake units, and your big data gets executed in a cluster of service, right? So again, let me remind you that you are not maintaining, you're not responsible for maintaining or managing these nodes, right? So all these green boxes are getting executed in multiple ADLA units, or the VMs, right, in a plain English. Right. So here, as you could see, the box on the left-hand side, with job summary is called job properties, right? So any query that you submit through either Azure portal or using Azure Visual Studio gets through the various stages, like I said in the previous slide, right? And on the right-hand side, what you're seeing is a job graph. Right, so when you submit a query, it gets through the Azure ADLA service, looks at your data and the parallelism request that you asked for and the availability of VMs. It creates a pattern, or the physical plan of how to execute the query along with the data that you submitted, and based on that, it creates multiple vertexes, or splits the data and executes it, or queries in multiple different Azure ADLA units. Okay, now let's look at how the job gets scheduled, and we'll also look at the various states in which the query goes through, and we'll also understand what is query and the priority in which you can submit the queries. Right, so here the same slide again with the various stages. We'll get into the detail of these stages one by one. Right, I hope you can see my current slide with the various job state and what does it mean on the right hand side, right? So as soon as you submit a new job into Azure ADLA account, it gets a status called new, right? The new status will last for some seconds or minutes based on the available units and the bandwidth and things like that, and how occupied the Azure data ADLA account is and things like that. So the various parameters and based on which the status moves from new to compiling, right? So once it goes through new and it gets compiled, the query that you submitted gets compiled by the Azure ADLA service. And once the compilation is completed, it emits certain intermediate files, right? So the intermediate files, we are going to get in detail, supremely detailed on how it compiles. Now, just for your basic understanding, it compiles your code into C# and C++ code, right? So you may be wondering why I'm bringing in C++. We'll look at it now in the next slides. And once it's compiled, so the next step is to queue, right? So the job gets queued into the ADLA queuing service, right? So what happens is when your job is into queue, Azure ADLA looks at the current usage of the ADLA service as a whole, because it's a PaaS service that many customers are using, many end users are using. So it has to basically look at your data and the parallelism request that you have asked for, and the size of the data and the query, and then basically look at whether Azure has got enough resources for it to execute the query that you have submitted, right? So once it finds that the relevant resources are available, then it schedules the job and then it starts the job, right? And then it gets into a state of running. Within the running, there are two states internally. One is that the query is actually running, and finally it will say finalizing, right? The difference between running and finalizing is running is actually processing your query, right? So your query may have multiple list of action. The first action could be reading from an external file, and then you may use some aggregate function, and finally there must be the aggregation of all the files executed in multiple different slave nodes or name nodes, right? So if you are coming from a map reduce background, you can easily relate this to a map and reduce job. So finalizing is essentially a reduce job which collects the data that was actually executed in multiple slave nodes and collects all the data and stitches together and give you a final output, right? And once everything is completed, the very final stage is ended. The ended could either be, it could have successfully completed the query, or it could have failed, or you could have canceled the job for whatever reason, right? So in either of the case, you will be billed for finalized state as well, right? So if you recall in the previous slide of the pricing, we said there's a cost for finalizing a query, and there's a cost for the number of ADLA units that you asked for, right? So you may be wondering why a job gets queued when I haven't submitted any queue yet, any job yet, right? So assume that you are first executing a U-SQL query for the very first time, right? So you may be wondering why my job is queued, right? I never executed any job, or never queued any job, right? So what happens is ADLA is a global service where multiple customers are using, right? So you may be querying a job, or your friend from another company might be querying a job, right? So what happens is all the queries submitted gets into the queue, right? And Azure internally looks at your query, like I said in the previous slide, looks at the query, the data, and the number of ADLA unit that you asked for, and check internally whether Microsoft Azure has got resources. In case, in the very rare case, if the required VMs are not available for processing your data, or in certain cases where the bandwidth is not available for copying or processing your data, in certain cases the job will be in the queue state for more time than expected. Right. So along with the left-hand side, you can also find a detailed log or history using the history tab on your Visual Studio. So in the interest of time, I'm not going to switch to the history tab on my Visual Studio. Let me move ahead, but just to give you information on where you can see the complete history of execution of your submitted query. All right. So so the other question that people have is how my job is prioritized, right? So when you submit a query, you got an option to ask for how many VMs that you want. I'm giving you in a very simple English, but it is called called Azure ADLA units in the context of ADLA service. But in a plain English, it is nothing but how many VMs that you're asking for, right? So that is called a parallelism request in the context of Azure ADLA, right? So when you submit a query, you got two options. One, you can ask for the parallelism request. You can start with 1, or you can go up to 20, like you see here, right? So and the next option that you can ask for is the prioritization, right? And how important your query is for you at this moment is what is called prioritization. So the prioritization starts at 0 and goes up to 1,000. So the least is the highest priority, and the larger number is the lower priority. For example, if you want a query to be immediately executed, you can say the priority is 1. Right, and let's say you're not worried about how quickly the job gets executed or prioritized, you can say 1,000. Right, so it depends on the priority your job gets queued or prioritized in the execution. Right, and the other question that customers or users ask: what if I give my priority as 1,000? Or let's say 1, and one more customer gives a higher priority. Or let's say Ilyas gave a query with a priority of 1,000, and another customer user say X, he has given priority of 1, right? If the query submitted by Ilyas is already executed or started getting into scheduling and running, it will not be disturbed. It will not be preempted. Right, because when I submitted, there was no priority 1, hence my query got started, and it is currently in running and scheduling stage. Right, and immediately after I started, another user, say X, submitted a query with a priority of 1. It will not preempt my previous query that I submitted. In other sense, it will be executed next to my query, although the second query submitted by X has got priority 1, right? So you have to understand this, very important. Now let's quickly understand how the job compilation happens within Azure ADLA. Right. So what happens is when you submit a query using Azure Portal or now Visual Studio, it gets into the compilation stage after it is queued, and while it is compiling, what Azure ADLA does it compiles the code and emits a C# managed DLL, right? So we will look at it in the Visual Studio itself. And on top of that, Azure ADLA also creates unmanaged C++ code, right? So there's a reason why Microsoft does this, right? So what happens is when Azure ADLA executes a query using just C# managed DLL, there's a drop in the performance of the query processing. In the meanwhile, what Microsoft did is they converted or executed compiled the same query into C++ unmanaged code, and when they executed the query against the unmanaged code, they could see somewhere between 10 to 20% of improvement in the query processing, right? So that's why Microsoft converts first C# and then C++. And it also creates algebra, which is nothing but the physical execution plan of your query, and also with other supported files. And all these files are created while the compilation happens. right? So you can find these, the execution or the supporting files along with the compiled files in your Azure ADLA store account. Okay, so to prove this, let me open my Visual Studio again. I hope you can see my screen. You can find the compiled files both in Visual Studio. So here, if we go to the execution, here you can find the resources that it has created. Let's give a second for it to download the resources file that has created, the compiled resources file. You can also see this in Azure subscription. Here it is. It has created a list of files. Here you can find the dll.cs file, right? So this is available within the Azure ADLS store, the Azure Data Lake store, right? And the way I came here is this. This is my Azure ADLS store account, and here if you go, you can find the Data Explorer, and within the Data Explorer you can find all my sample data set. Here is my sample data set, and here is my output files that I created, and here is my system files, which is nothing but all the compiled files are getting stored here. So here is some of the job that I executed. You go to U-SQL and you can find the execution. This is the one that I recently executed. Click on the 9 and you can find the complete list of files. So this is the compiled set of files. I hope you can see this. And here you can find the same file, the C# file, the CPP file. In case if you've got, so this algebra.xml is the schematic file, right? The execution plan that we saw in the previous screen in terms of the green boxes. You can also find this XML file. You can download it and you can visualize it, right? So let me close it, go back to my, right? So you come there by clicking on resources as well. So I'm jumping between screens in the interest of time. We got very limited time. So here you can find the same list of DLL files, CPP files, the text files, which is responsible. So these compiled files are copied to your slave nodes or name nodes wherever the queries are getting executed, right? So we are talking about a distributed system where you ask for multiple parallelism requests. So this is parallelism, right? So these two numbers, we'll look at it in the next slide. So let me again stop the screen sharing and go back to my slides. So this is what we saw in the Visual Studio as well as in Azure Data Lake Store account with the C# code generated by U-SQL, C++ code generated by U-SQL, and the user.NET assembly. So in my previous sample, there was no .NET assembly that I used, but like I said, you can also use your .NET assemblies, and your U-SQL script is also visible in this compiled folder. And to get to those files, you click on resources on Visual Studio, and you can basically find all the supporting files and compiled files of your query. All right, so this slide again shows the various files within your compiled folder structure. So the blue items, the output of the compiler, the Azure ADLA compiler compiles and emits these blue files. It is highlighted in blue itself, and the gray items are U-SQL runtime bits. So these are very important for ADLA to run the query against. Now we are going to get into the interesting part of the query execution, because this is what the internally happens within your ADLA, Azure ADLA, right? The query execution has got multiple things that includes plans, how Azure ADLA takes your data and looks at your query and looks at your parallelism request that you asked for, and looks at your priority and creates a plan, and how it splits the data and pushes into multiple VMs or Azure ADLA units and executes this data in those VMs, and the various stages involved in the query execution part, and how it parallelizes the query and executes your query very fastly. And we'll also look at the ADLA in math. Right. So this slide gives you a sneak peek of how a query life is within the Azure ADLA. Right. So as soon as you submit a query using Visual Studio, it gets into job scheduler and queues, like we saw in the previous slide, and it gets into compiler, where it creates and emits C# DLL and C++ unmanaged DLL, and internally Azure ADLA uses an optimizer. What it essentially does is it looks at your data that you have submitted. The data could be in petabyte or zettabyte, and it also looks at how many files that you have submitted. So in certain cases you might have submitted 1 GB of bulk file, or you might have split those files into multiple smaller files. So what it does is the optimizer looks at your query and looks at your parallelism request, and then it creates your algebra or the execution plan. And what it does is it creates a vertex scheduling. So what this means is if you have submitted, let's say, 100 files, 100 independent smaller files of data, and you have asked for, let's say, reading from those files, and then you're applying some transformation, and you're applying some aggregation function, or you're doing some joins, and it verifies all these data and with the optimizer, and it creates an execution plan, right? How many vertex? Vertex is essentially a small piece of job that gets executed in multiple VMs on the same data, right? So let's move ahead. Right. Again, I'm taking you through the same slide. So here we talked about the parallelism request that we have asked for. So in this particular slide, you can see the user has asked for 5 parallelism units. So parallelism is equal to Azure ADLA or equal to VM that the user has requested for. In this case, the user has requested for 5 VMs in a simple sentence, right? And what Azure ADLA has done is it has created 19 vertices by looking at the query, by looking at the number of files the user has submitted, looking at the multiple transformation or query in this case, and it has created 19 vertices. We'll also look at how the vertices the Azure ADLA creates based on the various parameters that we just talked about. All right. So like I said, vertex represent a fraction of the total work that you've submitted, right? So if you have submitted 10 GB of data in let's say hundreds of files, it creates hundreds of different vertices, right? So again, it is very important to understand your data by yourself, right? So you can see whether we can submit it 100 files or 200 files. It's completely up to you, right? So based on the files and based on the query, it then creates a set of super vertex. That's what you can see here. It calls SV on the green box, right? It creates a super vertexes by joining some of the vertexes together. And how it joins is basically based on the parallelism request that you asked for. So if you have asked parallelism request of 1, it will only execute 1 by 1 at a time, right? If you have asked for 4, let's say 4 parallelism, it executes 4 vertexes parallelly at the same time in multiple different Azure ADLA unit. Okay, so now let's zoom in into one particular box and let's understand what's within it, right? So here if you look at, there is something called SV, which is nothing but super vertexes. Super vertexes denotes a combination or a group of vertexes executed as a super vertex. Multiple vertices executed as super vertex, right? In this SV, there are about 252 vertices executed as a super vertex, and this is basically an aggregate function where someone has applied a sum or any other aggregate functions, right? And it has executed within 2.54 minutes. This is an average number. This is not 2.54 minutes for each vertices. It's an average of all the vertices put together, right? For example, it could, one vertices could have executed in 10 minutes. The other vertexes could have executed in 100 minutes. It's based on the complexity of the query that is applied on top of the data. And it has executed roughly around 4.3 billion rows in 2.54 minutes, right? And the number of TBs that the data has been read and returned, right? So you can see the complete information here. So at times, what happens is the execution can also fail, right? So the failure can happen for many reasons. It could be because of your query, or it could be because of failure at the Azure end, right? So the router can go fail, or the hardware fail, or VM had to be rebooted. There could be many reasons why a query is failed, right? What happens is this is completely abstracted from the user. The user need not do anything. If you see the amber column, which means some of the vertices has failed, at this time what Azure ADLA does is it executes multiple times. It retries multiple times, right? And then it will go green and the job gets completed. For any reason, if there is any problem in the query, the job will fail, and you have to look at your query and understand, and then fix that issue, and then you can re-execute the query. Right. So we have been talking about ADLA units, and I have been mapping it to a VM, right? On an average, one ADLA unit is equal to a VM with 2 core and 6 GB of memory, right? And this is roughly speaking, and this is not very exact. As per the current infrastructure given by Microsoft in the preview time, it is currently equivalent to a VM with 2 core and 6 GB memory. And you can ask up to 20 ADLA unit at the preview period, but in case if you are testing or evaluating Azure ADLA, you can raise a ticket with Microsoft, and they will go ahead and increase this count for you. Now let's quickly look at the efficiency and how you can verify the cost versus latency. Right. So for you to understand the cost and how you can compare the cost versus latency, let's go back to our Visual Studio. Let me show you how you can see this. Please bear with me for a second. I'm going to share my screen. Okay, I hope you can see my screen. So this is a sample query that we executed with a priority of 0 and parallelism is 1, which means I've asked only for 1 ADLA unit. I've not asked for 5. So click on the diagnostics, and here you can find the resource usage load profile for the diagnosis. So it says Vertex run too long, 0 issues found, so which means it has run too long and there's no issues. So to actually find out if there is any issues, click on load profile. So load profile means it actually downloads the profile from your ADLA account, and then it gives you the complete information, right? So to look at how the resource usage, the compute that you have given to this query, and how is it utilized, right? So I asked for 1 unit. There is no half a unit. The minimum is 1 unit, and you can also ask for 20, like I said in the previous slide, right? So here the query is executed. It has started at 0114, and it was fully utilized. So you're seeing, so the allocation and the runnings. Let's switch this off. So this was our allocation, and the query has started at 0.03, and until this time the ADLA unit was not utilized, and only at 28 seconds it has used the complete ADLA unit that I've given to the query, right? So this is what allocated, and this is what you have used for the query. So essentially from 0 to 28 seconds the query hasn't used the compute power that you have supplied for this query, right? So here there is a scope for you. So this is just a sample query. So in case if you're running with GB or petabytes of data, then you can actually see the actual power of how you can compare the latency versus cost. So here I've given 1, and I've actually wasted my complete ADLA unit here until the 20th second. At the 20th second I've used it to the max, and again it has come down, and the 32 second again it has gone up, right? So here you can actually compare what you have given and what exactly the system has used, right? And okay, so to check what could be the best compute unit that you can supply for your query, right? So this is a sample query, so we don't have enough data, but in case if you're trying or evaluating with GBs of data, then you can actually model as to how much of compute that you may want to give for this kind of query, right? So I hope this gives you a quick idea as to how you can model, how you can compare what you've given and what the Azure ADLA has used. Now let us switch back to our PPT and quickly ramp up the session and go further. Right. So this is what we did in the previous screen using Visual Studio. You clicked on the resource usage and you saw how much is the utilization, right? So in this particular sample, right, here the user was asked for 5 ADLA units, and the utilization of the query is only this, right? So the ADLA is not properly utilized, if you can see, right? So the actual utilization of the query is only in the beginning it has fully utilized it. On the rest of the query execution it hasn't used it properly, which means the user is actually wasting his money by oversupplying the compute. Right. So this is the modeling screen that I was showing with the Visual Studio, where you can model how much of compute power the query may require. So you can basically play with the number and give various number and see how much the query actually requires for 100% utilization, so that you can save some money on the query execution. I'm basically rushing because we are nearing the end time. So in case if you've got any question, we can catch up on the question window, or we can catch up offline as well. So this is a good example where the user has chosen to go with 100 ADLUs for the same kind of query, and the utilization is 100%, right? Although there is a drop here and there, but this is a good utilization. Right? So this is just to show you how much it will cost. So there's a basic cost for any job execution that says 5 cents plus plus minutes, the number of minutes that you execute into the ADLA units that you asked for, and cost per minute per ADLU. So you have to multiply plus the cost of the compute gives you the job cost of execution. Right, I'm going to skip this. So the blue line is allocated and how much you utilized it. So there is a gap here, which means there's a wastage of compute that you have supplied. So always make sure that the red line hits the blue line for the 100% utilization of the VMs that you supplied for the query execution. Okay, so now let's quickly look at the Vertex execution. What happens and how the file that you supply for processing your query gets executed and how it becomes a Vertex, right? So when you give a very big file for processing, what happens is it gets split into extents, right? So at this moment, there's no great information as to who has to split this data file. I mean, in the current documentation, there is no detailed information whether ADLA splits this data. But I suggest, in case if you're processing a massive amount of data, you better split those data and partition it so that the performance of the data gets increased. And for the safety of the data, the security of the data, Azure ADLS store replicates the copy into multiple other data centers, right? In case if one of the file gets lost, Azure automatically gets the copy from the other replicated copies, right? So and this is how a typical log file getting created, where you write log files into multiple smaller files and then you submit it to Azure ADLS store. Right. So this is just to show you a sample where if you submit only one file, there's a chance of creating only one vertex. Right. Again, if you submit multiple smaller files with queries, then there's a higher chances of creating multiple vertex files. Right. So that's how it creates vertex in the ADLAU storage, in the ADLA analytics account. And performance is one of the important things when you execute a query, right? For better performance, you have to partition your data. So let's now understand the importance of partitioning your data while you submit your query against the data that you have stored, right? So this is just a example of a clickstream data where there's a session ID and there's a list of domains and how many times a user has clicked on a particular link, right? So assume that there's a petabytes or GBs of data that you want to process. Okay, so here is a quick comparison when the data is not partitioned properly, when the data is partitioned properly, right? So here, there's a smaller files. In each of the smaller file has got the same data, which means Facebook is also here, 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 right? It is scattered in multiple files or extents. On the other hand, this user has partitioned the data, which means they've collected or stored all the Facebook related data in one extent, and the White House related file then in the second extent, and third extent contains all the CNN related data. So this makes easier for processing your big data. If you have so this is how we create and fill the table. For example, we create a table from the big data query, from the big data file that you have, and it creates a clustered index against the domain key through which you're going to filter the data. And it gets inserted into a table that is available in Azure Data Lake Store. Right. So, and this is just to show you how you find all the records where there is CNN.com using U-SQL query. I'm rushing because we are nearing the end time. Right. So here there's a file which contains. So this is just to map the same file previous slide where we saw same extent, same file contains multiple different data against a partition data where one extent 3 file contains only the CNN data. So this is going to be much faster. Right? So when the data is not partitioned, which means the same data is scattered again in multiple files, there is going to be a lot of expensive calls across multiple different smaller files that is residing in multiple different data nodes. Against, if you look at this example where the data is completely partitioned against the domain through which you're going to filter out, it is going to be much faster. Right? Because there is no expensive I/O that is going against multiple different files scattered against multiple data nodes. Finally, let's quickly see some of the best practices for improving your performance. Right? So basically there are only 3. The first one is learn U-SQL. For benefiting from the native U-SQL constructs first, and if you don't find, or if you have some reason why you have to look at user-defined operations using C#, then the optimization done by ADLA optimizer is going to be less. When the optimizer can't optimize your core, the performance is going to be weaker. Right? And thirdly, you have to understand your data. You have to find the volume of the data and how you can distribute the data and how you can partition based on the primary key that you're going to find out and how the data is going to grow. So you have to keep all these things in mind while you are creating a query or a job. Right? So basically some of these best practices that you can follow to improve the performance of your big data query process. I hope the webinar helped you to understand the capabilities of Azure ADLA and Azure ADLS Store for processing your structured, unstructured, and semi-structured data. Right? I hope you will get started with Azure ADLA within your Azure subscription. If you have any question, please go through Azure documentation that is available in Azure. Just go to Azure, search for Azure documentation. There are plenty of Azure documentation on all the topics that we just saw. In case if you want me to, if you want to touch base with me for any other further question, you can find my profile on LinkedIn, or you can tweet to me using the handler. Unfortunately, I could not take any of the questions because of the time constraint, but I will try to respond to you through your email submitted. Thank you so much for patiently listening to me and understanding the Azure ADLA capabilities. Thank you so much, and I'll see you in the next webinar. Thank you so much. Bye-bye.